Now we are into the next part of this presentation. We will discuss the design aspect that need to be considered for designing a broach, several parameters, cutting parameters, the complete tooth geometry, and finally the length of the broach tool has to be decided, which will take into consideration the load and the cutting forces which are generated due to broaching operation. Now, what are the several designing aspects for the broach? A typical broach should be designed or should be allowed with a sufficient rear end and a front end for clamping purposes. That is first and foremost important. And for a broaching operation to be done, the job or the component should have a predetermined hole. Either it should be drilled or bored, or in the forging operation or a casting operation it should be blanked initially. And the workpiece which is to be broached need to be very strong. Small components, fragile components cannot be broached because a workpiece, a strong workpiece is required to withstand the force that is required, the pulling force or the cutting force which is required for continuous cutting action of the broach. Now, in a broach there are several teeths, roughing teeth and finishing teeth, and the pitch of the teeth is defined as the distance from one point on a tooth to a successive point on the tooth. And for all the roughing teeth, one should remember they should be provided large pitch, whereas the finishing teeth can have fine pitches. But if the pitches are kept constant or uniform throughout the roughing and finishing teeth, then there is a possibility for chattering. The minimum stroke length should be of 25 millimeter, and the maximum stroke that can be considered is around 3 meter. For removal of material by a single tooth is very important. So ideally the total depth of cut, the material to be removed from these surfaces should be kept in a range between 0.5 to 6 millimeter, so that the material is removed by all the teeths in one go. The radius which are provided at the gullet spaces gives each tooth the strength and also assist cutting of the chips of ductile material, and the gullet space occupies the chip when it is removed from the workpiece surfaces. The tooth depth is always kept proportional to the pitch, and it must be sufficient enough to accommodate the chip. On each cutting teeth there is a land provision at the back with a small clearance. Certain tools, certain broaches are given both primary clearance and secondary clearance, and invariably the value or the degree is more or less 1 to 3.5 degrees for roughing tips, and it could be more finer, say 1 or 2 degree for fine tips. Now from this slide we will study the procedure for designing a broaching tool. For that we will study the nomenclature of a typical internal broach. Now there are two images. One is the virtual broaching tool and the schematic diagram of a broaching tool. Now from the schematic diagram we have to identify the cutting motion of the broaching tool. Now since the cutting motion is towards left, therefore the pull end will be at the left if it is a pull type broach. Now that means the other end will be the follower end. In between the pull end and the follower end lies the cutting teeth. 3 set of cutting teeth: roughing teeth, semi-finishing and finishing teeth. Invariably the roughing teeth will be of smaller dia and larger pitch, as we have discussed. Therefore we will have to find out the broach length finally, and that will include the length of all the teeth, that is roughing, semi-finishing teeth and finishing teeth, plus the shank length, which includes the pull end and the front pilot and the follower end. That in total will give you the total broach length. Now this slide will give you the broach tool geometry. Now the figure below shows a total broach with the broach length, and that includes the length of the shank, the follower length and the length of the teeth. If you take a small part of the teeth and enlarge it, you can easily see the various tooth geometry, or we can say the cutting tool geometry. The L shows the width of the length. P is the pitch of the cutting teeth. It is nothing but it is a distance from a point on one tooth to a similar point on the successive teeth. The clearance angle, this figure only shows one primary clearance angle. The radius which is provided to each teeth to support or to give strength to the cutting teeth, that is R, and which gives you a gullet space to accommodate the chip. Each teeth have a angle alpha, which is also called the hook angle, which is almost similar to a rake angle of a single point cutting tool. And as we have already discussed, the teeth rises gradually as it moves towards from a roughing teeth to finishing teeth. So there is a term which we say rise per teeth. Rise per teeth is nothing but the difference of height between two successive teeth. Now this slides gives you a clear picture of various tooth elements. Now at the top corner you can see the picture where the work with blue color and the motion of the tool, direction of the motion of the tool, and the term cut per tooth. The term cut per tooth and rise per tooth are similar. It is nothing but the difference in height between two successive teeth. Adjacent to that picture, the other picture shows the width of the line and the provision of two radius R1 and R2, which creates a gullet space to accommodate chip, and at the same time it also gives strength to the teeth. Now the picture at the bottom shows again the tooth element parameters starting from the relief angle, the pitch, the gullet space, the hook angle or the rake angle, and the total depth of the tooth. Now while designing a broach tool, the cutting teeth is the most important component of the broaching tool. Therefore, there are 6 points, very important points to be understood and should be kept in consideration while designing the complete broach tool. As you can see, there are different sections of the cutting teeth along the broach length: roughing teeth, semi-finishing teeth, and finishing teeth. The first set of roughing teeth are the smallest tooth, and gradually the size of the tooth increases towards the finishing tooth. The size of the teeth progressively increases as you move towards the finishing teeth, and you will see at the end of the rear palate there will be 3 to 4 finishing teeth of same size. The most important point is the rise of tooth, rise per teeth. This is usually greater along the roughing section or roughing teeth, and the rise per teeth along the semi-finishing section is less. Finally, the face of each teeth is grounded with a angle which is called the hook angle or face angle or rake angle, which is always determined by the workpiece material to be broached. For instance, if you are machining soft material, soft steel, then a larger hook angle is desirable, whereas for a hard brittle steel a smaller hook angle is required. Now this figure shows the motion of the broach tool. Accordingly, you can see the roughing tip is of smaller size and the size of the teeth gradually increases as you move towards the finishing tip. And at the same time, you can see the amount of material removed by a roughing tip. It is more than that of the finishing tip. And the other thing you can notice is the rise per teeth. We have discussed the rise per teeth is higher in the section, that is the roughing teeth section, compared to the finishing teeth section. Now first we have to understand what is rise per teeth. It is also called cut per tooth or depth of cut per tooth, or sometimes it is referred as chip thickness, and it depends upon shape of hole, size of hole, and the type of material being machined, and also the force available at the machine. Now this rise per teeth is very small and it is different for roughing teeth and for finishing teeth. Now the cut per teeth varies from a maximum of 0.1 mm for roughing teeth to a very low value of 0.01 mm for finishing. There are certain broach tools where the rise per teeth for roughing is kept at 0.3 mm and the semi-finishing teeth at 0.015 mm. The feed which we have discussed in this process depends on the rise per tooth, and the sum of the rise per teeth gives you the depth of cut. Now the total set of teeth, which includes the roughing and the semi-finishing and the finishing teeth, are to be designed for both heavy cutting as well as light cut. The first set of teeth, which are called roughing teeth, are always designed to do the heaviest cutting, followed by the semi-finishing teeth, and then the finishing teeth, which generally takes very light cuts. The finishing teeth generally are reserved for finishing operation. It does not remove the material, it only does the burnishing operation. It never does any work. So the finish produced by these finishing teeth is of high quality and it confirms the tolerance with a very high accuracy. Now the pitch is the linear distance from a point or from a cutting edge of one tooth to the corresponding point or the corresponding cutting edge of the next tooth. A relatively larger pitch is always required for roughing teeth to accommodate a greater chip load. Tooth pitch may be smaller on semi-finishing teeth to reduce the overall length of the broach tool, and the pitch is always calculated so that preferably two or more teeth cut simultaneously. This prevents the tool from drifting or chattering. And considering all this, we have to decide what should be the pitch for a broaching tool. Now, the pitch is the most important parameter of broach design and is decided in such a manner that at any point of time 2 to 3 teeth preferably are cutting in order to keep the cutting operation smooth, and the minimum permissible value for P is less than 5 mm, and the pitch of the finishing teeth is always shorter. It is almost in the range of 0.6 to 0.7 of the pitch, and the ratio of the gullet area to chip cross section is always taken as 3 to 5 for roughing and a value of 8 for finishing. These are the various formulas which are used to determine the pitch for plain broaches, for rotary broaches, and for surface broaches. Now, the tooth length is again an important parameter of the design. The figure shows the width of the length, which is represented by L or tooth length. Basically, it supports the cutting edge against stress, and each length is relieved by a very small back of angle or relief angle, and over the section of different type of teeth, the land width is not uniform. The roughing teeth generally has smaller land, say up to 0.25 mm, and this goes on gradually increasing up to 0.75 mm for finished teeth. So the average land width will be around 0.12 mm. Now, the general formula which is used to determine the land width is a value in between 1/4 to 1/3 of the pitch. The length of the tooth or tooth thickness always determines the strength, because these tooth lengths are designed to take both heavy and light cuts. Now, while designing the broach tool, two parameters need to be fixed. One, the tooth fillet radius, and the tooth gullet, that is the gullet depth. Now you see both the figures identify which is the gullet space, and there is a radius, fillet radius provided in the gullet space. Now this radius is very critical in order to facilitate the chip to curl like a watch spring, and it is discharged during the return stroke of the tool. Moreover, the hook angle or the rake angle, which is also called the shear angle, which should be around from 5 to 20 degree, which gives the direction of the chip travel. Now the fillet radius R is 0.2 to 0.35 of the pitch. This radius provides the strength to the broach tooth, and the depth of the gullet is always related to the tooth rise, pitch, and the workpiece material, as we have discussed in the previous slides. And the tooth root radius is usually designed so that The chip curves tightly within themselves, occupying as little space as possible.